And we are back, people. Let me just make sure that we have all the windows we need fixed. Remove that, pop that out, put that there, pop that out, and put that there. And we're going to go to that one. Let's change the URL. And that should be fine now. And transition. So yeah, long time no see. A couple of hours, perhaps an hour or so. Just needed to eat something and watch a bit of a show. So, what do we need? Right now we need this thing here that I have made. Doesn't really do very much. We need to be able to read memory and write memory. Division, perhaps. So we need to have memory. So we need to have a. There's also a interesting problem. How to deal with memory? Because you can have a block of memory. Let's say we have. Let's put it here. Static int 8 memory. So we have the memory, and that is going to be what was it, 12? What does it say? Okay. Right. How many bits do we have to work with in an address? This is 10. Let's say 12. So we have 12 times 1024. Be in memory. And you want to write to the memory and read to the memory. And we need to be able to load a ROM, basically. A binary file, I guess. That means we have to basically write a you have to write a what's it called? Compiler too, which I do not know how to do. I do not know how to do, really. But that will be interesting. We have to have so much stuff. Hmm. Is that correct, by the way? No, that's not correct at all. Wait. That's correct. That's not correct. That's not correct at all. We need this much memory. 4,095. 4,095. There's 4,095. Why the fuck? Where did I get 12 times? Where did I get that from? Hmm. That's more memory than it can have. And 495 bytes of memory is not a lot, considering each instruction word is 16-bit. Yes, it's not a lot at all. So should we just go full ham and have that much instead? Let's do that. That means at least we have some sort of consistency in the machine, I guess. We need read. You can read stuff in. So we have to be able to load addresses into memory and stuff like that too. So we have can move values between registers. You can set values in registers to a degree, but we need to be able to load high and load low, LL and LH. So the op for that is the register we need to load into. So it is R1. And then we need to have then is unused. UU, unused. And then the M. Zero, 1, 0, 1. I guess. 0, 0. That should be like that then. So, load immediate. And then we have basically the same thing here. But this is like that. Should I move? I should probably move that one up. Because then I can do that. It means that all of them who has that bit set, I guess? No? I thought I thought I was smart, but I wasn't smart. Uh, How does it work? Doesn't work really. Hmm. Well, I thought I could do this smart, but it seems I couldn't do it smartly. Um, I'll have to figure it out later. Doesn't really matter. It isn't real hardware again. So load high. Um, immediate, unused. And then we need the jump instruction. JMP. Op. I need register. Basically, only the register. I guess. This jump instruction, jump relative. Jump instruction would be basically having loading a value and then just plussing that to the current address. Rook could create problems, but hopefully not. Um, 0, 1, 1, 1. Nice. 0, 0. And 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. So that is the jump instruction. And this is R1. And this is unused. So it jumps to the address in the register. So that means that we can load the address. And we are out of space. 1, 2. That is not 3. That is 3. That is 4. That is 5. That is 5. That is 6. And we need what do we need more? We basically need a branch instruction 2, branch of 0, I think. What is called BIZ? No. B branch if 0. BQB jar relative. What does this do? Jump and link. Branch to an address in RAID register. Branch to register. Store PC plus 1 into register. Okay. Ah. I can remember something like arm branch if or if 0. Compare and branch on 0. Yeah. But I don't remember if that was the one. Was it? Branch 0. It's a good name for that. BNE. Branch if not equal. BEQ. Branch if equal. BEZ, I think, is the one we are looking for. BEZ. Branch of 0. That is basically the most easy way to do anything. Set skips the next if the if R1 is not 0. Yeah. I think you're about halfway through the amount of register. And that should be it for the branching. We have no loading. Loading addresses. Store SL. SSH. Store. Store low. Store high. Står det high byte of det ska det stå byte into register R1. Yeah, that's basically it. That's the same as yeah, that's basically store high and store low, and then we have to basically have load and load low and load high. We're going to read from an address, which is also going to be stored in a register. So we have to wait. That's wrong, right? You should skip if it's 0, right? Mm. Jump. Stored in R1. We need to have load LDL and LDH ST STL STL SH. No, store and load, that's wrong. SE set low, set high. So first we store the value. We have no shifts, by the way. Do we need shifts? Is that useful? Really like to have shifts. So shift. Up. Those are capital. Up. Up. Here we have it. Stalls. First we shift. We shift something a few set amount of times. Shift left and shift right. Do we need that? I say we do. Huh? Let's just implement it. Perhaps, I don't know. Going to just do this to begin with. The value should be stored in registers. In a register, right? Yeah. One. Then unused. Thought it was strange. Unused. Do we want that? Do you want to set a value? How many times should be shifted? Should just shift it. I say we just shift it. That's more fun. It's more useful, I guess. One, two, three, 4, 5, 6, 7. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9, yeah. Set. So how do we? I'm going to do that. I'm going to set the value of one register into the memory location pointed to by another. I guess. It's registered. Copy value of. They don't have any multiply and stuff in that one. I would really like to have multiply and divide, but I don't see how to do that in an effective way. How do I do that effectively? How do I do that effectively? Should just have. I'd really like to have two ways of setting values. Fuck me. I could. Set a high value, set a low value. The high value, set a low value. Set and retrieve. Right? Set and get. I'm starting to run out of opcodes. That's a problem. Really like to do that. I would really like to be able to just do something. I don't know if it's okay or right to do what I'm thinking. How do other people do this then? That was awful to read. I do have 14. I'm up here to 7, so I have more opcodes to use. So we can go to the next one, I guess. Get is does not, you cannot get values out of that. Makes no sense. What am I even thinking? So we have to load high, load. No, we don't need to do that. We just load LD. Just load the value directly into memory. So we need an opcode, and R1, R2, and unused. BEQ said. BQ said. BEQ said. BQ said. The thing is, I don't know if it's BQ said or BE said. Load. Anyway. Load. Load value in R2 into the memory location pointed to 2 by R1? No. R1. There we go. What's it called? Load and... So what is the opposite of loading? We have load up immediate, load store word, store the value of reg into okay, store and load. Load is the one that I'm thinking about, right? Load from memory into RAID. Okay, it should not be LD. It should be store. STR, I guess. Store. Store the value in R1 into the memory location pointed to by R2. There we go. Now we need to have the load LD. Oops. LD. And that's going to be that one. Load. 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 Store value in R1 is to memory location point of... No. That's wrong. It should be R2, R1. Load value in memory that 2 by R1 by R1 into R2. I guess. I think I'm done, basically. That's weird. I just need to add the whatchamacallit. Plus minus I have divide, I guess. Multiply and divide. Is multiply and divide, can I use the same one? Divide ISA. Because I'm wondering if you can implement divide as a function of multiply. I don't think you can. That's a problem. Shift left, shift right. Shift left and shift right basically is multiply divide by 2. So yeah. And then we have multiply and divide. Mul and div. And those are going to store the value into O2. So we can just this should be immediate. Do you really need immediate version of that? Because I now have the set high and low, right? Store load. Copy. Copy values into da. Do I really need that? That's what I'm wondering. Because I can just not have that, I guess. Only using registers would be nice. Would be very nice. Oh. Would be very, very nice. But I'm still very. I have still many opcodes left, so let's just continue. We can just add mul. Op. R1, R2, and unused. Mul and mulai. You really need mul. Let's just do it. That should be him. Needed value. Then we have div mil yank. Boost. Can have suppose divs. Yeah. Div I, yes. I really like to have all the immediate instructions be BBB. The immediate instructions should probably be something like that, I guess. That means it's Shift R and Shift L can't be can't be yeah, they can't be the same. They have to be something else. All the immediate instructions be all the immediate instructions should be odd, I think. Just so we have something that is two, three, four, five. Six can't can be that. Fuck it. 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14. I'm literally out of instructions now. And we're out of instructions. Oh goodness me. So I can't do anything anymore. Fun stuff, I guess. I was hoping to do something, have more instructions, but I realized that that's not going to work. Yeah, we have at least some instructions, I guess. Move does move 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 shift right, shift left, shift right, shift left. Yeah, that's okay, I guess. If this was a real computer, I would have to figure out a better way to do this. But oh well, it's not a real computer, so we don't care about any of this. Load, store. Load value of memory pointed to by R1 into R2. Store value in store value in R2. Store value in R2 into the memory location pointed to by R1. Memory location pointed to by R1 into R2. And that should be it, I think. I think that's a good one. And debug is fully like that. Now then. I have to assemble a program too. That comes later. When we have to build the assembler. Which is gonna be its own problem, I guess. Yeah. It's gonna be so fun. This can be so fun. Yay. So here's the logic. And we need to add more stuff, I guess. Um, add I. Right. DD P. And then comes add I mul. 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 Mul I mul. No, add I. Add I. Oh, oh no, we got one. Why do I have that? Mm, mm, I'm one off. Oh shit. I think I'm. I got too many instructions. Shit. Shit, shit, shit. I think I had too many fucking instructions. Oh my god. Shift left, shift right. Shifts are so useful, so I really like to have them. And I would like to move instruction 2. But I don't have any place for any of this. Uh, let me see. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 9, 10, 11, 12, 13, 14, 15. I've run out of fucking instructions. Oh my god. I did not think that would be go so fast. I could remove all the immediate mode, immediate ones, and just use registers. I think that might be actually a better plan. As I don't see how useful these would be. Let's do it like this. Now I can work on this. They really... Oh shit. Revert. Uncommit. Yes. Now we can write all. And now we can do that. There we go. Now we can remove the immediate. I don't like those. I don't really see a use for them. We just have to load values into registers and then act upon them. Shift left and shift right has to exist because we are shifting stuff. So yeah. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15. Yeah. Now we go. This is also used for add a negative value. 2. If we add, this can also be used for subtraction. Can also be used for subtraction, and that should be okay, I guess. So we can emulate different stuff. Still no file loading, by the way. Still no idea if this is gonna work. But we're gonna implement it anyway, even if we don't have any compile or anything built. Mul. We are not going to use any I instructions. We can split this. There we go. So we have add, multiply, divide. Div. We have shift left, shift right, mov. We got cell, cell. We got se. We got store. We got load. We got jump. Jump. And we got BQZ. BQZ. And we got last. And that should be right. Right. No, that's just F. And then we got unused. Unused 1. Unused 2. Div. Move. Mul. Div. Shuffle. Div. And now, and I also need to make a parser for this too, so I can use it when I what should I say? When I compile, when I make the compiler, so I can. That should be easy, I guess. That should be easy, I guess. Write emitters and stuff. Shift-L. And mob turn mob case sell. It'd be quite an ass to to program with, by the way. But oh well, it's gonna be fun, I guess. Mm, return sell case sir. JMP JMP um return case BQZ. So um I'm going to wait till the program, I guess. We do not have any of that, so that doesn't make sense. Now then, what do we have here? Um, we need to load of registers. It's gonna be basically the same. These are basically the same. Yank post. Um, but instead of this, it's this. And then we div. This is gonna be a problem, I guess. Or perhaps not. Div. Then we have Shift L. So we get a value, shift it, shove it back. Right. Case. Shift L. Int 16. How do we get the carry? Do I need to have an int 32 instead? And basically check if it's bigger than int 16? Okay, so first okay, so we need to get the registers, okay. Int 8. R1. That's all we need. We're not gonna care about the other one. Decode op. No, we don't decode op. We decode op. There we go. R1, and we just ignore that. Cannot pass value to an output to a reference parameter. Why? Why can't I do that? Just ignore it. Missing one argument. I guess that will do. First, we get the register, and then we get a value in that register, shift it, and put it back. So, int 16 r1 val equals to get reg r1 r1 um, oh, I don't know what happened there. Again, sometimes my computer just crashes. Not the computer, the desktop just. I don't understand. It just happens when I'm streaming. No session. Why does my session die? That's also weird. I didn't think that it would survive. That will not work. We need it to be we need them to be integers, right? Yeah, I think we need them to be integers so that we can set value needs to be integer 2. Um, get reg. Get reg. Okay. But none of this is correct. That's the problem. Does this actually produce the right code? I have no idea. Really want to set the carry to. Um, carry. Carry me home. um, do we have actually? A good question. A good question. Hmm. What? Malarok. Um. There's no carry stuff here. I'm pretty sure that shift left and right just truncates stuff. It doesn't really care if the result is going to fit or not. I would really like that to actually set the carry. Um, how do we set and reset the carry? I don't think we can really. Each instruction is going to do stuff differently. We're not going to have any carry. Good. Good to know. No carry. But that seems like too much work. Now then, to split this. No. Hello? Split. Split. There we go. After shift right, we have move. Move. Copy value in register in R1 to R2. So it's gonna be a decoder operator 2. We can just do this. Yank. Paste. We're not gonna do any of that. We're going to discard that anyway, so we can just we need registers and we need to set oops, undo. Set R2 to R1. Is that correct? Is that gonna be correct? I feel that that is wrong. Oh well. R1, R2, R1 val. I guess. And that is going to be MOV. There we go. And set high and set low is going to be interesting. It's basically going to be an immediate. With this one. Basically this one. That should be correct, I guess. Um, in mhm. Case. Cell. Mm. Yeah, I forgot to change the values here. It should be 12. Yeah, 12. Right? No, 10. I'm sorry. It's not that. It's the mask. Mask is wrong. Mask is wrong. The mask is wrong. The mask is wrong. Where's the mask? There we are. Mask 1 and mask 2. Change that. That. I think that's incorrect for some reason. Why does that look? That looks wrong. 1, 2. This is wrong. All this is wrong. Right? Yeah, this is wrong. Oh god. Oh god. Oh god. That is going to be so goddamn wrong. It's that is the correct one. C. That one is also wrong, I guess. First, that's C. C, and that those two. 3, 3, and then we have this mask. which is 3ff. And then ff. No, 3ff and ff. Uh, uh, oops. We're going to um, okay, these are never used, so I guess that's okay. That should now be correct, I guess. Yeah, that's correct, I guess. Three C 8 plus 4 is C, yes. Anyway, I forgot what I was gonna do. Distracted here. So we gonna use this one, I guess. Yeah. Decode op im. 8 R 1. Then we're gonna have to store the value somewhere. So you int 16 R im val. Then the code that one. Because we don't have a second value, we can just remove that. No, wait, that's correct. Yeah, those are the same. This is. Um, So we are going to have the opcode input, opcode. The output is R1 and im is going to be our im val. Uh, so first we're going to have to to val equals 2, 0. So first things first, we're going to have to set the because we can use these in any way we can. We have to get the register first, the value of the register, because we can't be certain if they're going to set the high or low first. So we are going to basically do both, I guess. Have both variants, and yeah. So first 8 bytes. Uint 16. Get reg, and the register we're going to get is R1. Now we have the value of R1. Yes, is it? R1 val. What the fuck is going on here? Okay. We're going to 0x 0f. That's the low values. And then we're going to add imval to R2, R1 val equals 2 im val plus we want to have to mask that too, don't we? Okay, where is that coming from then? Oh, and now we can set it back to the register, I guess. I don't really like that we have to use integers, but instead of unsigned integers, there shouldn't really be any problem because we're doing bit mechanics here. A bit mangling, I guess. We have set high. There's gonna be the other way around. I guess it should be not plus. It should be and hello. And that's or. What is and? No, not and. Not and. Yes, yeah, yeah, or. Yes, or. Of course, or. First, we. No, yeah, we order them. Yeah, 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 yeah. Okay, don't add them. We order them. But that's not. Store. Store the value in R2 into the minimum location pointed to by R1. So we need to do this, I guess. But it's gonna be str store and Then we to store the value of okay, we need the base address of the memory. Probably so it's just memory, VM memory plus something, I guess. Does that work? I need to get a pointer to the memory. Right. Pointer. Hello? Pointer's a type. Yeah, pointer's a type. So why doesn't that get highlighted? Uh, now we have the memory pointer, and we can um, to get register. Okay. We need to increment the memory pointer. Mm. And then we need to set no, we don't need to do that because it's an array. Yes, we do need to do that, don't we? Because we don't have the actual memory size and stuff. Need to dereference the memory. We need to equals that to R2 val, right? In direction. How do I dereference a pointer? No, that's not dereferencing. Pointers. Arithmetic not supported. Why? I have done pointer arithmetic before. Pretty sure I've done it before. Hmm. Um, cast this to a. Can I? The problem is that I have to store more memory than it can be fit in one place. Um, sharp pointer. Not sharp. Int 8. Hmm. Now that is wrong because the size of the object is wrong. So we need to um fuck me. I'm pretty sure I've fucking done point arithmetic. So why can't I now? Means I think I've done it. I don't remember. Oh my god, there's so much stuff. Um, I don't remember. Does that actually work? That's a problem I don't understand. That's one of the things I don't understand. I would need to point to that memory. That will not be correct, right? Mm, does that work? I hope it does. I think it does. But we have to make sure that all the values are below the threshold, which is that. If um, R1, no, it can't be. No, it can only always be the same. It's when we is when we um, it's when we you do the program counter stuff. We need to be very careful, jumping and stuff. Because jumping out of the program would be awful. I hope this works. By the way, I don't know. Um, LD. So now we need to um, get the values stored at that point and put it in R2. So um, set reg R2 memory dereference. some reason I wanted to be like that. That should not work, right? Address off. No. Um. I believe that that's going to be discarded, right? So what we can do is basically cheat a bit. I think that's that is going to work, probably, probably. Um, can we get an address of memory? What can we do with the address of the memory? Something I. What can we do with the address of memory? Um. Anyway, jump. Set the program counter forward. I'm going to set the program counter to whatever is in R1. And then we're going to increment the program counter by 1. So 2 last operations. So do we have one that only uses one decode reg? JMP. Oops. JMP. Rake. uint 8 R1. Oops. And we're going to decode op reg 1 op and out R1. Then we're going to get reg R1, and we're going to get reg. That's going to point uint 16 set reg R1 bal. No, not reg dot. We don't have the PC. That should be the first one. PC. PC. It's probably not going to work because I'm basically doing it wrong. Program program count and stuff should be unsigned integers, not signed. That's a problem. Right, that should dd pay. I think that's correct now. Another 2 hours or something. Right. Yeah, 3 hours. So I think it's time to go to bed now. It's midnight. So, right all, quit all. I'll see you some other time. I'm going to go to bed. Toots, bye. Have a good one.